This is Algebra 2 with Trig, Unit 2B.5b. We're factoring and solving polynomial equations. So what we're doing today is working with the same type of problem we've done in the past and graphing it just like we have in the past. So we're going to look at this, has four terms. So we're going to use factor by grouping to break it apart, to factor this apart. And we'll see if the parentheses are the same if factor by grouping worked. So we can pull out an x squared. That leaves with an x plus a 2. Bring down your negative. All we can do is factor out a 1. And that leaves us with an x plus 2. Because negative 1 times x gives us the negative x. And negative 1 times a positive 2 would give us the negative 2. So we could say that this equals 0 because we will be looking for the zeros of the function. So when we bring down our factor by grouping, we get x squared minus 1 and x plus 2. Well, x squared minus 1 is the difference of two squares. You need to be observant to what's happening with the type of terms you're working with. So if this is the difference of two squares, then we can say x plus 1 and x minus 1. We also have the x plus 2. If this is to the third degree, we're not overly surprised that there would be 3 sets of parentheses. It's not required, but there could be up to 3 parentheses because each one's going to represent a 0. Now what we'll do is set each of those to 0. When you subtract it across, we get negative 1. When you add it across, you get 1. You subtract it across, you get negative 2. So we're at 1, we're at negative 1, and we're at negative 2. So we're going to look at our degree. The degree is a 3. We're mainly interested in that being odd. 3 is somewhat important. 3 tells us that it can have up to 3 x-intercepts. 3 tells us it could have 2 turning points. But the main thing it tells us odd is that the end behavior is going to go in opposite directions. Our leading coefficient, you look at the leading coefficient, this is positive. When it's positive, that means it's going to head in a positive direction to the right. As x gets bigger, the graph is going to go to the right. If it's odd, that means it's going to drop to the left. It's going to go in the opposite direction. Now the question is, what happens in between? We notice that we do not have any double zeros. We've talked about those before. We've got 3 different zeros. That means the graph is going to go all the way through each one. The farther they're separated, the farther the 2 dots are separated, the farther it's going to drop down. We're not worried about how far down we go. We just want to be sure that we can clearly see that you went above the x-axis, you went below the x-axis. So then we write our equation, x cubed plus 2x squared minus x minus 2. This could have given us a hint here, I guess, at -2. We should have known that this could have come down as low as -2. We're almost there. Let's try one here. Looking back at the top, we still had end behavior. The end behavior is what is happening as the graph moves to the right and moves to the left. As x approaches negative infinity, as the x numbers get smaller, where's the graph going? F of x is getting smaller. As x gets smaller, f of x gets smaller. As x gets bigger, approaches infinity, the function is increasing. If you look to the graph, the further to the right we go, the more the graph goes up. So it approaches infinity. So we look at this next one. F of x equals negative x cubed plus 4x squared. One hint here is that it has a leading coefficient that's negative. We know just by that we don't want to have a leading coefficient that's negative. So I know I'm going to factor out a negative. I notice that they both have at least an x squared in them. The smallest exponent is x squared, so they both have an x squared in them. They don't both have numbers, so we can leave it as x plus 4. Now, when you look at x squared, realize that x squared is the same thing as x times x. The negative is a -1, so it's a leading coefficient that's negative. The x squared means that there's two x's there. So this is showing that this is going to be a double zero. And the x plus 4. As we review back here, as we factor out our negative, if we were to distribute this back in, if we want it to be a positive, this would actually have to be a -4. And that's because negative times a negative makes a positive. Now we will set each of these equal to 0. It's called the zero product property. Some say you can set the negative equal to 0, the -1 equals 0, and that's not a true concept. That's not a true statement. So that's irrelevant. So I wouldn't even spend time equaling it. We have 0, and we have 4. We notice that the leading coefficient is negative. That means that this is dropping down. The largest degree is 3, so it's odd. That tells us that it goes in opposite directions, so this has to be increasing. Now the question is, what happens in between? If you think how this flows through here, it either has to come down and bounce out here at 4, or it has to bounce off of the 0 and come down. Because the 0 is squared, because there are two x's to represent the x squared, because there are two x-intercepts that are exactly the same, that is your double zero. So it's going to bounce at 0, it's going to go up, and then it would come back down. Should go through that, actually. So we know our end behavior. as x approaches negative infinity, f of x approaches positive infinity. It increases. As we move to the left, the graph goes up. As x approaches positive infinity, the graph goes down. As we move to the right, the graph is falling. We'd finish this off by writing our equation. Negative x cubed plus 4x squared. Our last question that we have, we're looking at the dimensions of the jewelry box. So if I make a sketch of a possible jewelry box, I'm sure this looks like just like everyone else's jewelry box. This is a rectangular prism. So the volume for it is length times width times height. They give us the dimensions. They say that the length is 2x. So it doesn't really matter which dimension you consider length, but we'll consider that one the length. We'll say this one is the width, and the height is x minus 3. So our volume is 24. We have our length, our width, and our height. So we're multiplying the three dimensions to each other, and when we do that, we should get an answer of 24. Now we're trying to figure out, what do we need to do? How can I solve for x in this situation? Well, one method, we would want to turn this into standard form. So I could start out by foiling my two binomials together. So I have 24, I have 2x. This is going to become x squared. Minus 3 and minus 1 gives us a negative 4x. A negative 1 and a negative 3 gives us a positive 3. Then we're going to distribute the 2x through. That gives me 2x cubed minus 8x squared plus 6x. And then I could subtract the 24 to the other side. Notice I need to make the polynomial equal 0. You don't want the polynomial to be equaling 24 or any other random number. So now you have to decide, what do you do to break this down? How can we figure out x? If I could get it into factors, then I could use the zero product property. Some might think that it was factored earlier. Well, that's somewhat true, but it didn't incorporate the 24. We have to get the 24 involved. So this has 4 terms, so we're going to use factor by grouping. So I can factor out a 2x squared. That leaves me with x minus 4. Factor out a 6. That leaves me with x minus 4. Notice the parentheses are exactly the same. That has to be true for factor by grouping. This gives us 2x squared plus 6 and x minus 4. Now I kind of look at it, and I could factor out another 2, but I'm solving, so it's irrelevant. It doesn't change the answer. So we're going to use the zero product property. So this would be x squared equals, when we subtract the 6 and divide by the 2, we get negative 3. When we add the 4. Now we know that when you take the square root of both sides, you'll end up getting x equals plus or minus I root 3. Well, that's an imaginary answer. That means it's not really an answer. It's not going to help you figure out the dimensions of the box. X equals 4 is a much more reasonable values of x equaling for the dimensions of the box. So we know that the length is going to be 2 times 4, so that's 8 inches. The width is going to be 4 minus 1, so that's 3 inches. And the height, that's going to be 4 minus 3, so that's going to be 1 inch.